Hello everyone. Today we are going to see the sequence detector problem based on Mealy model. Already in the previous video we have been discussed about the sequence detector basics. We have seen the types and we have seen the model also. So next we are going to see the one example problem. So your question is design a 11011 sequence detector using Mealy model. So first you have to know how many number of states is required. If it is Mealy model, you required n states. If it is Moore model, you require n plus 1 state. Already you know what is mean by n. N is nothing but your number of bits given in the sequence. So here they have given 5 bits. 1 1 0 1 1. So this is your sequence. So total number of bit is 5. So n is equal to 5. So you have 5 states S0, S1, S2, S3 and S4. And always remember that whatever the sequence they have given, that should be taken as an each state. So initially I have started with S0, then S1, S2, S3 and S4. And also write the sequence whatever they have given. So from S0 to S1, your input is 1. Similarly from S1 to S2, again it is 1. This is my second bit from your sequence. And third is from S2 to S3. My third bit is 0 from the sequence. And fourth bit is 1 from S3 to S4. Now we are going to see how to complete the state diagram by using your overlapping method, right? So already I said that I'm going to start with S0. This we are assuming that it's going to be your reset state, right? So if it is a reset means it was retaining in the same state. If your input is 1, it is moving to the next state as S1. If your input is 0, it is retaining in the same state because we are assuming that S0 is going to be your reset set state. Next, I got my first bit of your sequence. Next, it is in S1. Again, if your input is 1, it is moving to the S2. Okay. If your input is 0, where it has to move? So just I've considered as S1 means 1 because whenever your S0 is 1, it is moving to S1. So I'm considering this S1 is 1. S2 is this 2 bits 1 1 and S3 means my bits 1 1 0. Next S4 means 1 1 0 1, right? I have written all the bits. So it starts from your S1 because S0 is completed. So if you are taking a S0, if your input is 1, it is moving to S1. If it is 0, it is retaining in the same state. Now we'll see the S1. If it is 1, it is moving to S2. If it is 0, where it has to go? See, this is my bit. So I have written here. The next bit is, it's an option, right? So only S1 means it's like a state. So you have only two options. Either you might have your input as 0 or else you might have your input as 1. If it is 1, it is moving to S2. If it is 0, where it is moving, we are going to check that one. Just take this bit. What is the value of this bit? 0. Just see this bit and compare with this bit. If both the bit are same, it has to be retained in the same state. I'm repeating again. Take this bit and check with this bit. If both the bit are same, it has to retain in the same state. Wherever you are staying, you're going to retain in the same state. If both the bit is not matching, again you have to move to the reset state. That means when your input is 0, it is moving to the reset state. So input is 0, my output is also 0. Next, so I have taken S2 is equal to 1 1. Again I am taking an option 1 1. Same bit I have taken. and my third bit might be 0 or might be 1. If it is 0, it is moving to the next state as S3. If it is 1, what is going to happen? Again, take this as first 2 bit. Both are same. Again, compare this 2 bit. Both are same. So, if both are same, you have to retain in the same state. That means whenever your input is 1, it is retaining in the same state. Right? Now come to the state S3. So already I said that S3 is equal to 110. Again I have taken this and my bit might be 1 or might be 0. If it is 1, it is moving to S4. If it is 0, where it is moving? Again, take 3, compare with this. Right? Consider this. So, again, take this last 3 and this last 3. If it is 1101 means it is moving to the S4. So, here we don't have any issues. And come to this point. So, 100, you have a 100. Just take this 100 and compare with this. If it is both are same, it has to retain in the same state. If not, take the last 2 bit and compare with this. Again, both are not same. Again, take the last 1 bit and compare with this. If it is same, it has to move to this particular state. If not, it has to move to the reset state. So, whenever your input is 1, it is moving to S4. If it is 0, it has to move to the reset state. Now, we are going to complete the state diagram. Just see, my sequence is 11011. Here I got 1101. Next bit should be 1. So I have an option as 11010 or 11011. Whenever your sequence is completed, my output should be 0. If not, whenever your sequence is completed, my output should be 1. If not, my output should be 0. Okay, so just see the last sequence 11010, right? 11011. So whenever you're completing the sequence, my output is going to be 1. You're going to check where it is going to move. Just take the last 4 bit and compare with this. It is not matching. Again, this is also not matching. Take the last 3 bit 010 110, it is not matching. Again 011, it is not matching. Take the last 2 bit. Here is 10, here is 11, it is not matching. And take this one, this is 11. Here the last 2 bit is 11. Here also 11. This 11 is equivalent to S2. Now what is the meaning of that? The last 11 means, right, it has to move to the from S4 to S2. When it will be moving? Whenever your input is 1 and output is 1. Why it is 1? My sequence is completed. 1, 1, 0, 1 and 1. So whenever my sequence is completed, my output is 1. Next. What about this one? So this is matched with this. So it is moving from S4 to S1. And see here, 2 bit is also not matching. And take the last bit and compare with this. Again, this is not matching. If it is not matching, what I have to do? You have to move to the reset state. So when it is moving to the reset state, whenever your input is 0, my output is 0. Right? So this is nothing but your Mealy overlapping method. Right? Thank you. If you have any doubts, you can put it in the comments. Thank you.